Okay, section 1.3 is the law of conservation of mass. Before we get to that, however, we need to understand the difference between mass and weight. Mass is the quantity of material or the amount of matter in a material. Okay, matter is whatever can be sensed. We already said that's what matter is. So it occupies space and can be perceived by our senses. Okay, but mass and weight are not the same thing. Okay, so as this example shows, the weight on Earth is 560 newtons. Okay, so you notice that while we tend to use pounds or grams and kilograms, that's actually not weight, because weight is the mass times the force affected on that. Versus the weight on the moon is about 1/6 of that, so it's about 90 newtons. However, the mass is constant. It doesn't matter if I'm on the moon or if I'm on Earth. The mass is in that kilograms of 56 kilograms. Okay, so mass is the amount of material. It's constant no matter where you are. If you're in space, and which has no gravity, you'd have zero weight. But weight depends on both the mass and the gravitational force. So if there's no gravity, you would have no weight. All right. Now, Lavoisier, who also discovered oxygen, came up with the conservation of mass. Okay. So here is a solid material. Okay. Let's say it's iodine or something like that, or carbon dioxide. That's even better. Okay, dry ice. Okay, it says coal. It's completely burned. All right, and so I have a little bit of solid left, but nothing else is there. But yet everything inside the jar still weighs 100 grams. So basically, what this is saying is that the material inside this bell jar, which weighs 100 grams, even though it has been transformed into something completely different, still weighs 100 grams, and that's what the conservation of mass is. In a chemical reaction, the matter is neither created nor destroyed. It's transferred into something else, which means that the mass of the reactants, or the things that you start with, is equal to the mass of the products, which is what you end with. And that's what the conservation of mass is. The total mass remains constant during a chemical reaction. So the words that I use there are reactants, which is starting material, and products. I'm going to go down here. Products what's left at the end. If anybody likes to cook, okay, another way to think about this would be that the ingredients that you start with are your reactants. The food that you eat after preparation would be considered to be the product, okay? And so basically what we're saying is that the mass of the reactants must equal the mass of the products at the end of the reaction, okay? So here's the problem. Some iron wire weighing 5.6 grams is placed into a beaker and covered with 15 grams of dilute hydrochloric acid. The acid reacts with the metal and gives off hydrogen gas, which escapes into the surroundings. After the reaction, the contents of the beaker weigh 20.4 grams. What is the mass of the hydrogen produced by the reaction? Okay, so basically I have the mass of reactants must equal the mass of the products. That's what the conservation of mass says. Okay, so what I have here, 3 different masses, and it's asking for 1. Okay, so I have 5.6 grams of iron. I have 15.06 of hydrochloric acid. I have 20.4 grams of contents of the beaker. Doesn't say what those contents are. Beaker. And it's asking, so the question mark is the mass of hydrogen gas. So the question is, what's what? So iron, would you consider it to be a reactant or a product? Okay, it's there. The key is that this word right here. So anything that comes before this word is a reactant. So therefore, this is a reactant. The hydrochloric acid is also a reactant. The contents of the beaker is a product. And the hydrogen gas is a product. So what I have is I have the mass of the iron plus the mass of hydrochloric acid has to equal the mass of beaker contents plus the mass of hydrogen gas. Okay, I don't know why I have two S's there. So the iron was 5.6 grams. The hydrochloric acid was 15.0 grams. The contents of the beaker was 20.4 grams. And this is what I don't know, so I'm going to make that X. Okay? So when I add these two together, I get 20.6 grams is 20.4 plus X. I need to subtract 20.4 from each side, so I have 20.6 minus 20.4 is equal to X. So 0.20 grams is equal to X. And that is my overall answer. Okay? And this is the end of this video.